The technical presentation that you're attending right now is breaking down testing silos. If you're, this is a 10:30 to 11:30 presentation. Welcome everybody. Happy Cinco de Mayo. I hope your time at the CxEnergy conference has been productive and exceptional. I thank you for attending this technical presentation. The course that you'll be looking at now has CEU credits. We'll go quickly through the general information that's provided in terms of getting credits. There'll be some questions that I believe they'll be providing to you to answer that we'll be covering at during the presentation. So let's talk about the course description. As companies have a project and they have their various stakeholders that they need to do the work of the project, commissioning manager, commissioning agent, the designer, construction manager, vendors, the client itself, the facility folks, pardon me. Everybody is trying to accomplish a certain goal of their contract, their scope of work, so that they can work towards the goal of the project. Unfortunately, what sometimes happens in being focused on those specific goals, they don't necessarily all fall into a common vision of the project. And unfortunately, when that happens, communication winds up being minimized. There's not a lot of collaboration, and you develop silos. So this course is going to be talking about silos in the testing area on projects, and specifically the factory acceptance test and the silo that generates, the startup testing work and the silo that generates, and the commissioning work and the silo that generates. There's testing done by the construction folks in terms of they're doing their NETA work, they're doing flushing and hydros and megas and what have you, but we're not really looking at developing a synergy with that right at this level. We're really talking about areas where the groups that are involved in each one of these areas, factory acceptance test, startup, and commissioning, can somehow get more of a synergy, more of a collaboration effort, working more towards a common goal, and basically breaking down silos. That's why I came up with the name for the course. I thought that was a good idea. And being a commissioning agent, I've seen where the inefficiencies and the duplication of effort can sometimes easily be avoided. We're going to be talking about that during this course. We're going to talk about what happens during factory acceptance tests, a brief overview of that, startup, commissioning, and where their similarities and differences are. How we can plan to integrate that better, to focus more on common goals versus the silos. As we're looking at the factory acceptance tests and startup and commissioning, what makes them up? What's the same? What's different? What do they do? What are the problems with some of the things that they do? And how can we kind of work that? What are they and what can they be? Towards the end, we'll talk about how we can institute some of this collaborative effort and achieve a better efficiency and duplication, minimize duplication of effort. When I took this, started to present this paper, I was looking at it very much just as an engineer that's been doing this for quite a while in different industries, power industry, the pharmaceutical industry, federal buildings, office buildings, both from a standpoint of I've done field work, I've done startup work, I've done construction management work. What I didn't realize when I started to research this and look for different information is that this is a common problem throughout various industries, whether it's an IT firm or just a regular business firm, where folks get so entrenched in their work and they create their own silos that it becomes territorial, it doesn't become collaborative, there's a lot of miscommunication, a lot of lost communication, and the overall vision winds up suffering. So it's not just what we're going to bring out, which I was surprised to see how many papers I found throughout the various industries talking about how this is a common issue that management has to actually look at the culture and look at what they can do to make the changes, how they can reorganize and things like that. So what we're trying to get out of this is to learn what, for folks that are more well-versed in the FAT version or the startup version or the commissioning version of the project, we're going to be looking at some of the similarities and some of the differences. As I said, we'll talk about how we can look at programs to implement changes. Sometimes it's bound by the culture of the organization, the nature of the work, that because of the budgets, because of the schedules, because of the way it's been done before, you can't make big changes. But even small changes that allow you to break down silos to some extent will produce a good return on your investment and work towards having a more collaborative effort. So we'll talk about that, how we integrate the work together, how we'll be more efficient. As I said, my name is John Hitsos. This is the 20th anniversary of my 25th year as an engineer. Saying it that way doesn't make me sound so old. I have a background in both pharmaceutical and military and hotels and power plants. Two projects I worked on that have really been kind of special to me have been the World Trade Center in New York, the transportation hub, also known as the Oculus. And before we collided with Congress, I was working on the super collider out at Waxahachie about 30 years ago. I've been with Jacobs for about 13 years. So let's talk about the silos and how we look at what's happening. And hope you like my artwork. When we look at the startup work, when we look at the FAT work, when we look at the commissioning work, as I said, there are certain requirements. They wind up creating silos. And as you can see, the silo on the left and the middle and the right, they're not talking with each other. So some of the things are the same. You're going to have startup, commissioning, factory acceptance tests. They're going to be identified to some degree in your MEP specs, your CSI specs, whether it's Division 1 for an overall commissioning spec, or it goes into Division 1 possibly for FAT and startup, or they may be within the commissioning, the specifications, the MEP specifications, Division 25, Division 26. That's a typical thing that you're going to see, and how well that gets done and how we look at that for integration is one of the areas that we'll be talking about. The FAT is obviously done at the factory. The startup is done in the field, and commissioning is done in the field. The areas that we're looking at are done at different times by different people, and sometimes not where one person can help the other person or can even be attending the other person, the other facility. You'll have somebody that, like a commissioning agent, he may come on late in the job, and the opportunity for him to do an FAT has already passed. The equipment has either been tested already or it's delivered. So a lot of it has to do with how things are scheduled and how well we're looking at the project in terms of scope of work, where people can interject themselves and that interface can be capitalized. If you're looking at a factory acceptance test, sometimes you have it, sometimes it's value engineered out, sometimes it's provided and spec'd out to have a factory acceptance test, but nobody witnesses it. It's nobody from the client's organization or the project. Usually that's, if it is done to any degree, it's really the designer of record. He'll attend. Client may attend if somebody does actually attend. Very rarely will the opportunity come for a commissioning agent to attend for most projects. I know in the pharmaceutical industry, that's exactly the opposite. They want you to attend. They want the commissioning agent to make sure that he's doing the review of this, because there's certain opportunities for maximizing the effort that are presented if the commission guy or the facility engineer can attend. With startup, again, you have something that's identified in your MEP specs. Sometimes it's in a Division 1 spec. We'll talk a little bit about where things are located in specs to, again, integrate the work a little bit better. Typically, the startup engineer is looking for that specific component and only that specific component. He's not necessarily looking at if the HVAC is interfacing with the BMS for the controls. He wants to make sure that he's basically energizing the gear, that he's meeting the warranty requirements, that it doesn't explode when you turn it on, that it does work, it gives you the right values, and he's in and he's out. So the primary people that are involved with that are obviously the vendor and whatever that particular contractor is. If it's a HVAC device, that'll be the mechanical contractor. If it's an electrical device, it'll be the electrical contractor. Sometimes with the CM, occasionally we can get the commissioning guy there. We'll, again, be talking about how we can have consistency and overlapping requirements if at all possible. But it usually is scheduled way before commissioning, and again, maybe something that the commissioning agent can't attend. It is a requirement for commissioning. It is a prerequisite for commissioning, but it may occur well before the commissioning agent is on board, depending upon how that particular job is set up. Commissioning, you'll typically get a Division 1 specification that says overall, regardless of what specification, MEP specification you have, whether it's mechanical, electrical, plumbing, it tells you what you're supposed to do. It gives you a plan. It basically says, contractor, make sure you're providing enough dollars in your budget to accommodate this program. And that commissioning is actually a program that is for the entire project. Some folks look at it like, well, there's a commissioning agent, he's doing commissioning. Well, anyone involved on the project is part of the commissioning team, whether you're a vendor, whether you're a contractor, whether you're a designer, we all have a contribution to make, and there's our roles and responsibilities that interface back and forth. So the commissioning plan, which comes out of the commissioning spec, will integrate all those roles and responsibilities, identify when they're supposed to happen, and things like that. A lot of times, folks, when they're looking at a commissioning job, especially some of the smaller jobs, commissioning is just tied right at the end of the job. It's a bulk of time put on the end of the job. And unfortunately, that's kind of the worst way, because you're basically saying that the main thing to check out your quality assurance is done at the end of the job. And if you're having any problems, you're not giving yourself any contingency to fix the problem, to get it resolved, to identify if something is going, it's not running the way you intended it in the owner's project requirements document or the basis of design document. And again, as we're talking about some of the things where we can improve, if you can get it into, my goal has always been on a project is to move things forward. Try to move the process, the review, to the extent possible. You don't want to redo things and do them over and over, but move them forward so that you can find the problem with the people that are most knowledgeable about the problem and have the most opportunity to fix the problem. If you can fix it in the factory before it comes to the site, that's great. If you can fix it up in startup before you do commissioning, that's good. You want to be able to integrate those things so people are aware of what they're doing, and we'll talk about that a little bit more. So I hope you like this, folks. I think this is a great little cartoon here. But when you have silos, you have issues with the silos. You have duplication of effort because the startup guy is doing what the FAT guy is doing what the commissioning guy is doing. And if they don't talk with each other and they're not aware of each other or they're not aware of their programs, they just repeat the stuff. Obviously, you can get territorial, sometimes even adversarial, and you're not sharing information where what helps Group A, startup, commissioning, FATs, what helps them do their job may cause somebody else to have a lot of extra work if they're not collaborating. And I'll give you lessons learned from that, which I just had from a government agency that we're working out in Washington State. They decided to have an FAT, And they spelled it out in fairly good detail that they wanted certain activities for a generator to be tested at the factory. But they didn't include any time for anyone to go out to do the witnessing. They didn't want to spend that money. It wasn't necessary for them to do that. So as the commissioning agent, took a look at the test documentation that I finally got, what I saw is that when I compared it to the requirements in the specification and in the owner's project requirements, if they had to do function A, B, C, and D, the test document only showed that they did A and B. And when I brought that to their attention, their idea was, well, that's going to get done in the field. And I, again, brought it to their attention that that's not what the spec said. Commissioning, all we can do is not create work. All we can do is identify variances. We can identify how something is not in accordance with what was identified as project criteria, whether that criteria is in a drawing or in a specification or in a balance of design or a basis of design or a owner's project requirement. There's a contract document that basically is saying, here's what I'm paying you for, and here's what I expect you to comply with. So when I looked at this and I saw that there was a variance, and I said, look, have you guys asked for a waiver on some of these things? Has somebody asked for some difference? And it says, no, we intended to do that at the site. Well, here's an example of now people moving work backwards instead of forwards. Work that I might have been able to vet and say, okay, this requirement, I don't have to repeat this because the FAT clearly showed it, well documented. I can just say, as a commissioning requirement, you met that requirement. I don't have to repeat that. Well, if it's not done, even though it was identified as being required during the factory acceptance test, now that work's got to get done in the field. And if it gets done in the field and there is a problem, well, you don't have the components necessarily. You may not have the people that are technically qualified to find the problem. And it's taking your guys in the field time and effort to fix it. So collaboration and communication is very important. And again, one of the things as we're looking at goals, sometimes, again, you have a contract, definitely have to meet all the budget requirements for your scope. You have various segments of work that you have to interject your time and effort at. A lot of times, most projects, they'll be looking at, I have a discipline on floor 1, I'm working on area 5, whereas commissioning is looking at more of a systems, a more holistic approach. So you can see that there are differences in the way people are attacking the problem of getting the job done. And the problem is if you're in a silo and not looking at each other, you're not necessarily capitalizing on available skills. You're not necessarily looking at the schedule in a way that you're not duplicating effort or creating additional work. And as I said, I like to try to push items forward as much as possible. So we want to do something like breaking down these silos. And I'm sorry, that is not to show that their silos are taking off. That was the best picture I can get with a silo falling down. They're not taking off, they're coming down. When I looked at that later, as I was looking at the presentation, I said, I wish they were at a slightly lower angle, but I was not able to grab that. Part of breaking down silos is going to be change. If your culture is, this is the way we did it before, we're not going to revisit that. We're not going to have a general review of the various folks that are involved with the project once things get awarded, whether it's design, build, doesn't really matter. However it's presented, whatever your project organization is, if you're not looking at it from an overview of saying, how do we want to have everything work together, then you're just doing it like you did it before. You're just copying a spec that was done before and changing some of the values, changing some of the titles. And we all do that to some extent because we're not trying to reinvent the wheel. But to break down silos, there has to be some change. The primary part is that the individual goals definitely have to be unified. You have to have a unified vision where everybody's understanding that their piece meets the requirements of the goal and not their requirements fall into the overall vision. And however they fit together, they fit together. If there's a gap, there's a gap. And gaps are not good. When Rocky said, she's got gaps, I got gaps, together we fill gaps, that's not the way you want it to work on a project. What you want to have on a project is you want to have the handoff from one person to the other. You want to have the integration of one person's activities to another so that it will work and function together and give you the most optimization for how everybody can work together. Everybody has to have the same agenda overall. And sometimes, as you may recognize some of these examples I'm giving you and some of these points I'm bringing out, you may see that that doesn't always happen on the project that you're at. A lot of times, people aren't looking at the actual workflow. What's your predecessor? What's your successor? What do you actually need? I've been on some pharmaceutical jobs where that is a very important function that we do almost every week. Obviously, there's a certain cost to that, and you have to have that in your budget. There's certain time that has to be devoted to that. But however you do it on a weekly basis, monthly basis, however you're looking at it, if you're looking at your predecessor and your successor relationships, you're identifying how you're going to build your critical path. What's it going to take to get the job done? Where are your workarounds? If everybody is just providing a schedule that's not integrated and doesn't understand how what I do affects how somebody else is working, hey, I'm working on the first floor, that's all I'm worried about. Well, I got VAVs on the second floor, the third floor, and the fourth floor, and I have to test that air handler to see that it all works properly. Well, I'm not going to get to the second and third and fourth floor until next month. Well, do you test part of it? Do you go back and do interim testing? Again, there are a lot of different options to consider, and I'm not suggesting that there's one option better than the other, but you have to have a plan in advance, because if I'm writing a commissioning protocol and it says, test this as a system, then I have to wait until the very end, because I don't have a system. If I know that there's going to be partials, we did that at the World Trade Center, where they had certain air handlers that only went to certain areas, and they weren't ready to build the rest of that particular basement area, and there are 4 basements in the infrastructure. We knew that going in, and we built the test so that we were actually doing interim tests, and each one kind of stepped on the next one, stepped on the next one, stepped on the next one. We minimized some of our rework because we knew that going in. Any barrier that you have that forces people not to talk together is an issue. You don't want somebody to say, well, I don't have to necessarily send that email to everybody or be transparent. So marrying up protocols, and a lot of times commissioning is because they're at the end, they can do that in the best possible way, is saying, well, what's involved in the FAT? How can they prove some of these things that I'm going to be doing? Or how can at least they be doing a dry run for what I'm going to be doing? And again, while you're doing this, while you're looking at this kind of a program, and that's a little bit of a change from some of the typical, you do that, you do that, you do that. If you could integrate that together, you're moving problems forward. If you find out, we had a generator in an enclosure on a project I worked at, and everybody did the review. It was a very good review. We went on the FAT, and it was good that they allowed us to go on the FAT. As a commissioning agent, I went on the FAT. So the generator has to open some vent blades so that they have air coming in so that the generator can work. And what we found out that the light switch for the inside of the enclosure was right by one of those blades. And it was impossible to see that from just looking at the shop drawings. But when we got there, we saw that was a problem. Anybody who was going in and needed to turn on the light, if that vent blade was open, was going to score their hand. I know because I was the guy that actually opened the light, and it almost happened to me. They had to fix that, and they had to fix it before it got shipped out. We wouldn't have known that until it got to the site, and then how would we have really adjusted that enclosure to make sure that it met that requirement, where it was much easier for them to do in the factory. Incidentally, if anybody has questions, we'll have some time at the end, but if anybody needs to, just shout out and we'll try to get to them as best as we can. So what you want to do, as I said before, in terms of change, you want to try to rebuild. If everybody's looking at your triangle where commissioning is doing pre-functional checks, construction checklist items, and functional checklist items, the construction guys are doing their general QA, QC, mega field tests, what have you, NETA tests, and then they are working with startup. And the design folks and the engineers and the owners are looking at factory acceptance tests. If each one of those, if you're looking at this guy here, and this guy here, and this guy here as individual elements, instead of that overview, that red silo kind of encompassing all of them, that's really the program. That's where you want to try to rebuild a little bit. And a lot of that just depends on what's allowed for that particular project, for that particular owner, for that particular budget. So let's talk about what the individual items are now that we kind of provided a little bit of an overview there. With the factory acceptance test, the best part about the factory acceptance test, if you can get one, if it's allowed, if it can be budgeted, is that you're doing a dry run with the people that are most knowledgeable to tell you whether or not the design engineer really knew what he was talking about. This is not to criticize or in any way talk about the design engineer not doing his job. I know because I was a design engineer, I wouldn't want anybody to say that about me. But a lot of times what you think is going to be the way to meet the OPR, the Owner's Project Requirements, in terms of here's, the Owner's Project Requirements gives you the bones. You're putting the meat on the bones, what you need to do. So this is going to be, here's how we do it. We're going to take this air handler, we're going to have this motor control center, we're going to have this generator, it's going to be this size, this capacity, this voltage. That design engineer may never have started a thing in his life. He may never have actually been to the field or has limited time being in the field and identifying construction. So is he really aware of clearances? Is he really aware of how you do maintenance on the thing? Is he really understanding what's involved with the energization of the gear? So you're now in the factory with people that are very knowledgeable, and you can be looking at the sequence of operation, basically be doing a dry run, which will help you shorten the amount of time it takes to write a functional test procedure, and understand exactly what really needs to be done in the startup, because if your generator produces whatever the capacity is, that's not going to change when it gets to the field. But some of the field installation things you want to be looking at in terms of this might have been a problem in the factory, you want to see if it's a problem in the field. And all of that can be done as a dry run. If you have a question, if you want to find out if that's the most optimal way to do things, because again, sometimes you're not talking directly to the designer. I have very few projects as a commissioning agent where a designer comes in and we have a chance to get together and talk about how does the system work? What are the details of that system? What did you expect or not expect? I have a spec, I'll have product data, I'll have a sequence of operations, and I'm reading dry information, trying to figure out how this might work differently from where I had it somewhere else. These people can tell you they're the subject matter experts. Again, you'll find opportunities to find problems, and if there's any additional information that you might need, I've had many times when I've asked for an O&M early, what I consider the right time, but early for what the project was identifying as a deliverable, and was told I couldn't get one. I've gone to factory acceptance tests where if I ask for a document, you're like the visiting royalty. They're trying to make sure that they're making an impression on you to see that you're doing something good. And yes, there's a cost in terms of time going out there, some airfares, hotels, or whatever. But the return on the investment there, which may be a little bit more sublime, a little more subtle, is all of the work that you save in the field, all of the issues that you have in the field that don't occur because you've been able to address it. Plus, a lot of times, both as we'll talk about in startup also, a lot of times when they're doing a factory acceptance test, if something goes wrong 5 times, you only know about the result that went right the 6th time. You don't see the effort and the issues or the problems. And if that's an item that happens several times, you might want to know about that as a trending thing. You might want to know that, hey, this might be the weak spot in this element. Maybe that fuse always blows. Maybe this fan belt always gets tangled up. They'll tell you about they had a successful test, especially if you're not witnessing it. All you'll know is that I very rarely have seen somebody where they give you a chronological history of running the FATs and all the problems they had until they got to the successful version. I've worked for a manufacturer, and I'm ashamed to say it, but I was pretty much able to pass every FAT, even though I had sometimes parts missing, because there was a way to get around things. And if somebody wasn't witnessing that or wasn't cognizant of what the actual function was, you know, you did what your bosses told you to do to make sure that the factory test was accepted, and then try to fix it later on. So having a witness there is keeping everybody honest and giving you information and getting information from the people that are most knowledgeable. That's a kind of a general checklist. Again, as you develop something, that's just something that kind of shows what all is involved in a factory acceptance test. The issues is that sometimes you don't get a chance to see FATs. If you're doing 5 or 6 things, a lot of times they'll say, well, let's look at one. Let's not look at all the others. Sometimes it's factory acceptance test isn't done, or it's not witnessed, valued, engineered out. And if you're looking at the specification, the problem also is if the person who's writing the specification isn't aware of the requirements that you need, how it fits into the owner's vision, he's not giving the contract, in the contract language, he's not giving enough requirements. So if later on somebody says, well, I didn't have to do that in the FAT, and you're trying to look at, well, yes, you should have, because maybe you know about that from a previous job, or just in general how you test a UPS or an HVAC unit or FCU, and then you look in the documentation and maybe there's like 2 or 3 lines. And maybe instead of having a Div 1 overall FAT document, which is what I kind of was noting before, you have individual guys writing their FATs. So the guy writing the UPS spec, he may be very knowledgeable and his FAT requirement is pretty detailed. But maybe the guy writing the generator spec, he's not as knowledgeable of the field, so his FAT might be 2 or 3 lines, if that. An overall FAT in Division 1 basically sets the requirements. And that's something that might be looked at as a possible change to facilitate this issue. Do you get the FAT protocol from the vendor early? It'd be nice to get that early because then again, before, whether you're witnessing it or not, you have an idea of what he's going to be checking. If you don't get that document, you have no idea what's going to happen until you get the results. And if your spec is a little bit weak or not very detailed, at least if you get the protocol, you have a chance to say, wait a second, why aren't you checking this? Because most specs, even if they don't tell you specifically, do this during an FAT, do this during a startup, do this during commissioning, they usually have some kind of performance requirements overall. So regardless of where that performance requirement is identified and documented, it's got to be done. Having that as part of your protocol review will help make sure that you have that compliance. Again, looking at a punch list, part of punch list generation is being honest, identifying what the problem is and what you're going to be doing and how you're going to fix it. And if it was fixed, you want to have that because you want to have that as some of your baseline information. I've seen FAT punch lists where basically there was one line, scratched component X, or the magnet helix gauge is busted, we'll give you a new one. And it's like, well, you did a lot of work. The FAT was maybe a day long. Did you have any problems? If you're not there to witness it and you're not there to help develop the punch list, then you'll get what they give you. So what it can be, and I talked a little bit about this already, is if you're putting in the spec what you want it to happen, what you want to see, then contractually they have to give you that. You're paying for 4 tires, you don't want to get 3. You're paying for have the car tuned up, you don't want to get it and have the old spark plugs in. So if you are looking at their protocol, if you're putting this information in the spec, that helps. If you're bringing the right people so it's not a candy trip. We had an autoclave for the pharmaceutical work that I was doing for sterilization, and 2 of the major manufacturers on 2 different projects I worked on. One's in Milan and the other one's in Sweden. You can imagine that we had a lot of people that wanted to go on those trips. They knew jack about what the actual equipment did, but in one way, shape, or form, they were associated with the project and they went. The guys that went to Sweden actually met the Swedish bikini team. They had a very good time. But when we got that autoclave in and we actually tested it, we found that the chemicals that they were using for sterilization actually deteriorated the rubber seals on that particular autoclave. It wasn't compatible. That should have been tested there, but they didn't necessarily look at that they were using the same chemicals. They did an autoclave test that people weren't really paying attention to some of the details. Having a commissioning agent there, and if at all possible, having a facility engineer. Your facility engineer, a lot of times, unless it's a brand new place that has no history at all, he's aware of how he needs to get the building done. Smaller jobs, that might not be something that you have, you're contracting that out. But if you have an in-house guy, especially somebody who's been working on a facility like a federal facility, military facility, where that facility is around for a while and going to be around for a while, you'd kind of like to have him be there, because if he has a problem with what he's doing, then he could find out how to make it better, or he could express why he's having a problem, which maybe somebody didn't think of before. If you're looking at the FAT has an overall plan. You're looking at what they're going to produce, how it meets the plan, and how it integrates. That's what it can be. The startup silo works the same way. It is a typical startup form. It's performed by the vendor, may or may not be witnessed by the commissioning agent. You'll get it's very focused on the equipment, not necessarily the system. So if your air handler is the air handler and an outside exhaust fan and VAVs and whatever, they're looking at they're looking at that component. You might actually have the tab guy have to come in, the BMS guy have to come in, the VFD guy have to come in. They may not necessarily be looking at equipment at the same time and adjusting it at the same time with everybody. We had really good success when I worked on a job for a pharmaceutical where the tab guy was working with us pretty much for the entire time that we were on the job. So as he was making changes and adjustments, we were learning about how the system worked better. So you do get a checkout of equipment. Again, how is it detailed in the specification? A way, and we'll talk about that it can be better. Obviously, the focus here for the vendor is the warranty. He's going to try to make sure that he's ready so that the warranty kicks in. So you want to make sure that if there's something that he wants to fix, he's fixing it before you have to rely on the warranty. The issues are that if you don't have that third person there, things can be overlooked. Sometimes startup is actually done by the contractor. If he's familiar enough with the gear, the vendor doesn't necessarily come out to look at some things. It depends on the complexity of the gear. It depends on the project. But if somebody says, hey, I've worked with UPSs all the time, I don't have to have Liebert come out and check something. If that's part of the way that they're going to try to save time and save effort, the problem is that not the SME that you want to have there. So who comes out and does the work, what they're going to be doing. When we had some UPS lessons learned where we didn't have the BMS connected at the time, so they were doing some UPS startup. And then we found that the UPS wasn't really providing the signal to the BMS for the alarms, for the supervisory alarms and what have you. When they tested it, they looked like they were getting the right voltage, the right current coming out to simulate the alarm, but it wasn't done that way. Well, for the purposes of the startup, he was okay with it. For the purposes of commissioning, we found an error where we had to figure out why that wasn't occurring that way. Again, how the MEP spec is detailed has a lot to do with it. What are you asking for that startup to be? What do you want to see documented, and who are you going to allow to be doing that? A lot of times, if the commissioning agent can actually work with the startup guy, at least towards the end of the startup duration, there's a whole bunch of things that he would normally have in his functional test that actually can be performed by the startup guy, documented and written off, and he does not have to do the duplication of effort. If you're coming in at different times and you're not allowing that interface, then what happens is you're doing exactly the same test and everybody's looking at each other like, well, didn't we just do that somewhere else? So what it can be is, again, all of these things can work together for integration. If you're looking at the protocol, if you can get the protocol for startup, then you could say, hey, wait a second, this doesn't match the spec requirements. If I have seen startup protocols provided to me, and it's almost basically a blank sheet of paper. And I said, well, wait a second, where does it show that you've identified that you're meeting this voltage requirement? That it's not just a qualitative, yeah, it works good. The spec is pretty straightforward and pretty descriptive. You want quantitative. You want, well, what's the voltage? How many GPM do I have? What am I getting? The thing, having something that just basically says, I have complied with the specification, everything works good. Well, yeah, that's good if you want to go to a trial and you want to say that this guy didn't do his job and you want to, look for monies or something. But in terms of getting the job done, you want to be able to say, what have you done? What are you going to do? Same thing with the punch list, same thing what's in the spec. Vetting these things out, what you're trying to do, again, move things forward, minimize your rework. Commissioning is the same exact way. What are you identifying? And one of the things I like to see is understanding what the commissioning effort is, understanding what the commissioning program is. Like I said, in the beginning, have a good kickoff meeting, have people aware of how people are going to interface so that they don't think that commissioning is just done by the commissioning agent. Commissioning is a project requirement. It's not an individual company's requirement. We're trying to do QA, and it's a little hard to do QA if walls are buttoned up and you're doing all the work at the end of the job. We're testing silos. Our test silo is to look at sequences, to look at modes, to look at equipment itself, but to look at how they interface with each other. Sometimes we're running integrated tests. And we're giving the owner a baseline documentation. So he can say, if 5 years from now, 1 year from now, 6 months from now, things are not working right, why aren't they working right? Where are they deviating? Where's the problem? Why am I getting I'm trying to cool down the building, and instead of being able to get 70 degrees, it's constantly at 74 during the summertime. Why do I have black mold on the wall? Why is there condensation? You're giving him a baseline that says, we've checked everything out. We've met all the owner's project requirements. As far as we know, everything should work great. And if anything happens from here, you have some place to kind of look to see where you're at. We make sure that training is done. We make sure that all the requirements for you to operate the plant are there. The issues that we have is sometimes we're limited. We come at the end of the job. Not everything gets commissioned. There are a lot of systems that don't get commissioned. I'm working on a job where I'm doing lighting control. I'm doing some distribution work, but the generator is done by somebody else. It's not part of our commissioning effort. What you do and how you sample things, if you have 5 MCCs, they may say, just check one. And if you have a problem with that, then check another one. You have lighting control. Do lighting control in 3 rooms. Do 5 VAVs. If you have 50, do 5, do 10%. Whatever the percentage that everybody agrees on. Something's 100%, you do every air handler, but how much you sample, let's face it, if you have 50 VAVs and you check 5, that 6th one could be the one that's really bad, but you didn't check it. And a lot of times the major issue that we have is the program is set up to look at, I'm working in an area, I'm working on a floor, I'm working with a discipline. I'm not necessarily always looking at the system unless that's built into the approach. So if I need to have something that's on the roof that's working, an air handler or whatever, that's working, that provides zones on the 1st floor, 2nd floor, 3rd floor, whatever, if that's not integrated and they're not ready, do I wait until the end of the job? Do I do partial and then have to do it over again? Again, you want to build that in early, and that's going to be an issue if you don't. A lot of times also the master schedule is made by the construction manager, does not consider the commissioning workflow. Commissioning has very specific requirements, very specific predecessors and successors. Build that into the schedule for the equipment. If you're just looking at, I buttoned up wall X, well, what's in wall X? We had working with Harvard, where we did a general review, and I was able to be on site for much more time than I normally would on some jobs. And as they were working and almost getting ready to finish the wall, it would be like, you have a VAV here, but there's no access plate for that VAV. So how do you get to it? There's an FCU that's in the ceiling, but you've built basically all of your piping and your cable tray around it, so now I no longer can get to any of the controls, any of the wiring, or actually open the door to the unit. We can see that, and we can work together, and again, move that forward. If you're waiting until the end of the job, you might not even be able to see that happening. So you're not necessarily present. And on some jobs, one of the differences I found working with pharmaceutical, they basically ask commissioning to be there as kind of a third set of eyes as people are doing the pre-functional. Most jobs, the commissioning writes the pre-functional, gives it to the contractor, who fills it out. That pre-functional gives you an idea of what was bought. Was it the same thing that was spec'd out? Was it installed correctly? Is it in good shape? Is it damaged? So that, is it started up? You're ready now to do a functional test, commissioning guy. We're filling it out for you. Well, so we're writing the PFC, pre-functional checklist or construction checklist. Commissioning agent is writing the functional checklist. We give that to the contractor, he fills it out. That's basically our means of verification, where we can identify whether or not he's meeting the requirements. Now, we're hoping that he's going to be honest about it. We're hoping that he's filling it out accurately. But because our scope is typically limited, that you can't be in the field to do even a sampling, that's the only way that you can actually say, okay, we're going to come down. The problem with that is if he isn't correct, if he isn't accurate, then instead of being DONE, you're DUN, which means all of the work that has to get checked, verified, and looked at has to get done basically while you're in the field to do functional tests, and instead of a 3-day trip, it's a 5-day trip. So, there you go. What it can be is if you can bring commissioning early on jobs, that really helps. We had a job for Southern Connecticut State University, and they brought us in while they were doing some of their initial design. So when we looked at some of the specifications, we were able to look at and identify constructability issues that needed to be identified in the specification. For example, most universities are going to be around for a while. Most of their facilities are going to be around for a while. So they need to be able to look at their life cycle requirements to see whether or not something has to be replaced within a certain period of time, because the life cycle of that material, component, gear, whatever, is going to be run out at a certain point. A lot of times the manufacturer's label does not say the year of the manufacturer. They might have a code, but it doesn't have the year. And especially now, as from what I've seen on electrical gear, where companies have changed, gone out of business, merged, if they give you a code, it may not be a code that anybody understands what it really means. So if you want to know whether that panel was done in 1950 or 1970 or 1980, you don't really know. But if you put that in the specification, you'll get that information. So what we looked at when we looked at the FATs, and we looked at the startup, and we looked at commissioning, you can see what they are, you can see how they fall into silos, and you can see how with certain changes that you can make those silos come down. There are similarities and duplications of effort. If you're looking at it from a program and you're trying to build that and reorganize and maybe make some changes, you can see where just sometimes a simple discussion, sometimes just making sure that the email is distributed to the right amount of people will help people understand why something was done a certain way. So you're not repeating the same thing. If you have to go step A, B, and C, and you think you can go step A, C, and B because you figure I'm doing the steps, it doesn't really matter what order it is, maybe somebody can tell you, no, it really does matter. You communicate and you build common goals. And that to me is always the main effort that you want to make sure people are working together. You don't want to have an adversarial relationship. Everybody wants to get their job done. If you're an engineer, you want to do your job. Regardless of the company you work for and when you come in on the job, you're an engineer. You want to get the job done. You're a problem solver. So you want to be able to solve your problem. And the more help you can get, the more work you can identify what that problem is, the better it's going to be. So having folks that are consistent and provide consistent information, share information, eliminate some of the turf wars that you have, all of that is going to maximize your efficiency. It's going to minimize duplication. As I mentioned, there's various things that you could look at for further information. As I mentioned, I found within different industries, there's a lot of this silo breaking that seems to be very important to folks. Not so much that you don't do your job, but that you understand how doing your job may affect somebody else. If you're working towards a goal, and in doing your goal, which saves you a minute or 5 minutes or just gets your job done, you're actually creating work for somebody else. You know, I think of one of the last things I wanted to mention is I think of we work with the building folks, and we were putting in a large piece of, we were putting a large double-ended substation in. And the doorway was put in such that you basically had to tear down the wall to get the gear out if there was anything that happened. Whereas if people looked at it and understood the size of that gear, because the gear was put in before the wall was finished. So if people understood that, you know, there are ways that you can make the transom over a doorway be able to be removable, and you don't have to tear anything down. But they didn't do that. The structural guy, people that were doing the concrete work, they worked one way and they built what they needed to build. The guys that had to put in the equipment, put in the equipment. If that equipment failed, if we had a problem, and we did have a problem in testing it and it had to be removed, you had to break the wall down. If people aren't looking at how you install things for maintenance requirements, and you don't have that, somebody identified that. I had that on a nuclear job where the valve stem needed to be removed so that you could work on that valve. Unfortunately, the valve was pointed towards the wall. So the only way you could do that, it was either rip out the pipe, which had already been hydrostatically tested, and it was stainless steel pipe and was very difficult to do that, or you actually had to make a hole in the wall and make an access plate, which had to be rad-proof because that was a radiation area. And it was extra work that didn't have to get done if the valve had just been changed to a different direction to start with. Folks, that's the presentation I have. I hope you feel that you have an idea of how sometimes, without knowing it, people create silos, how those silos sometimes can actually impact a job and they don't allow you to be as efficient and collaborative as you can, how they sometimes get in the way of your project goals. And maybe in understanding that, we can make changes, big or small, that will help that be minimized. If anybody has any questions, go right ahead. Yes, sir.
A lot of this is kind of changing the process of what's typically specified by an RFP. So how do you recommend making that change? Are we talking the design engineer, the owner, who's, you know? Well, this isn't something a commission agent's going to be able to
recognize, as I say, I recognize that, and that's why one of the slides actually just said to make a change. Some of it is presentations like this to make people aware of that situation. The other part is if the commissioning agent is involved early on out, then he can be bringing out that the points that we just made, that as you're building the specification, as you're in the 35%, as you're in the 60%, as you're in the 90%, you can work some of that into the specification language so that people are aware that part of their job is to have an early kickoff meeting. It's not to wait and put commissioning at the end and segregate startup, is to make sure that there's protocols that are being generated and transmitted back and forth. So the earlier that language can be put in, but if people, as I mentioned, if people are looking at, well, let's do the job the way the other job was done, what you can do is, on a smaller level, you can just maybe not start from the top, which is the best way, but start in the weeds, so that if you're working together with somebody, and you can establish that through kickoff meetings and making sure that the right people are at the meeting, at the very least, you're having some transparency and some collaboration. It's better if it's mandated, but that involves a little bit of a change and a little bit of a change in structure. Some projects don't allow that.
And then from the factory witness test, so you're indicating to try and get, whatever startup, pre-functional, functional, get as much of that moved to the left as possible. I guess typically what I run into, if everything's done at the factory witness testing, I'm very satisfied, I'm happy. They ship it to the field. I do another inspection, make sure everything's still the same it was. But as soon as subs and vendors and everyone else starts getting their dirty little fingers in there, I've got anything that's not sealed and hasn't been tampered with, I've got to go back and inspect and test, anyways, regardless.
I recognize that, and that is an issue in terms of knowing how to install things. We had some UPS testing that was done, and they did it while the construction was still going on. So all of the debris was tested in the factory, was brought in, and we had problems with the UPS because the construction dust had accumulated on terminals, and they weren't really ready for that. They should have waited until that environment was sealed up. So it's part of the process of knowing what's required and how you can make sure that you're keeping your equipment protected. I had a red waste system that I was working on. We built red waste systems. Basically, as waste came in, we mixed it with sodium silicate and Portland cement, put it in 55-gallon drums, moved it around to pick it up with a crane, put it in the high grad area. And they had a take-up reel so that as the transfer cart moved back and forth, it kept the cable, because there was the cart had to be powered to move. It kept the cable from going onto the floor and getting jammed under the transfer cart and rubbed and what have you. That's all it did, was just a take-up reel. It wasn't a winch, but somebody thought it was a winch, and that area wasn't protected. And we came in, did our testing on Friday, and when we came in on Monday, the take-up reel was gone. none of us would have thought of like, why, I'm sure somebody thought they have it on the front of their pickup truck and they think that they have a winch, but it literally won't do that function. But how you protect something is part of what you're looking at and how you seal things up. And a lot of times, let's face it, that's something that people aren't really paying a lot of attention to, and it winds up making them do work several times. When I'm doing commissioning, as you just mentioned, and I get in there and I open up the device and it's covered with debris, it's covered with dust. I don't want to, especially if I'm doing electrical testing, that debris might be conductive and I might have arcing between my phases. I don't want to, that guy's going to have to come in and clean that because the room wasn't maintained, and now I have to come in and wait. Instead of doing my test, I have to wait until they clean it and make sure that they've removed that. It is an issue, but it also can be something, again, identified in the specification and identified as a predecessor, because part of the commissioning is we ask, is the room clean? Is the components damaged? Are we, is everything being taken care of as a prerequisite to doing the functional test? Any other questions?
Yeah, you mentioned the master schedule having just a block for commissioning at the end. Are there specific commissioning tasks that you recommend they include in the master schedule? And if so, what are some of the more important ones?
I don't know if you can see that little flow chart on the bottom there, but basically we've identified in a little pictogram some of the major elements that are there. On some jobs, the project controls guy can actually say, for gear A, I'm put all of these on there so that we can actually be monitoring it. But some of the things that you want to know is, when is it mechanically complete? When is the startup being scheduled? It'd be nice to say, when do they think that they can have the pre-functional checklist completed and provided to you? Because before you do a functional test, you do want to be able to review that. It'd be nice to get the startup report and with that, so that you can look at it and say, okay, yeah, I see what your issues are, I see what you've done. Things don't have to be 100% perfect for a commissioning guy to come in, but they have to be done to the extent required for them to comply with the test functions. Otherwise, you're basically running a test that you know it's going to fail. So that window there, and my emails on the last page, that's just, that's not proprietary. That's just looking at elements and just putting them together. So that's something that if somebody wants to get an example of, I can give you a better picture, because that's a little hard to read. But basically, when you want to do your functional test, when you want to do your startup, when is it mechanically complete, if those are even things that are addressed by the contractor, is he actually saying that there is a mechanically complete time so that he can now schedule his startup? Is he doing startup while they're still working on the gear? So part of that is you want to define what those elements are, but then those are some of the elements. Submittal reviews, FATs. If you are doing an FAT and part of your FAT is you want a punch list, you want an FAT report, again, that could be in the schedule that says, before you ship that, I should have an FAT report that's acceptable and approved. Yes?
Yeah, I'll just expand on it. So basically on the commission schedule, what I try and make sure is implemented into the overall project management schedule. It's going to require a task or action or review or anything from me to make sure that the contractor then has identified their completion date and that's I don't care what their duration is unless I want to go inspect and observe while
Right.
they're executing. That's fine, I can have that. I'm looking when it's going to get delivered in my duration.
Sure. I'm sorry, in the back?
Yes, I was wondering about the integration of these steps into the specifications, and if you've had pushback from the design team or the construction team, and I was wondering what steps you might have taken to overcome them, because unless these things are in the specifications, more or less in the way you describe, you're really not going to achieve this kind of integrated workflow. So that's my question.
So, and it's a good question. Commissioning can't create work. If we did, we'd have to pay for it. And no commissioning group I know wants to pay for work that's not being done by the client. So I don't usually get pushback from the design group, because usually they understand that we're looking at an area that they're kind of light in terms of how they're, but if I'm coming in late on the job, that's when the pushback is, well, we've had this spec out for 6 months through 6 reviews. Now you're coming in at the end. We're just ready to go to IFC, and now we have to do a revision. There'll be some pushback there. If the spec is already done and it is IFC, to get a change is difficult. I get more pushback because of when it gets reviewed or when it gets introduced. The client is usually very interested in hearing that we're identifying a possible problem area that can be avoided by just making sure that the work is done. And it could be something that he says, hey, you know what? We didn't think about that. Let's pay our contractor to do this extra stuff. There was nothing in a specification that said for a job that we're doing up north where the gear that came in, they were getting at different times. It wasn't necessarily that the building was finished yet, and went into a laydown area. I think part of it was in an outside area, part of it was in a warehouse. It wasn't a heated warehouse. So we said, well, you should have a space heater. Well, there's nothing for the space heater because when it works, the facility's up and running, we don't anticipate that. I said, well, from a construction point of view, normally we don't tell construction how to do their job, but if you're not mandating that, then you really should add that they need to do that to protect the equipment. It wasn't a major cost to make sure that they came in with a light bulb or they had temporary power for that particular area, especially the stuff that was in the laydown yard, and making sure that they provided that so they didn't have condensation. And we also told them about putting rodent screens around some things because we were finding that they were having varmints come in, and weather is bad outside, nice and dry inside a component. So put something like that, even if it's just to tell them to wrap it. One of the things that I found, and again, usually it's also the way you come off. If you're trying to come off on a collaborative effort, it's usually well received. If you're trying to come off that you're telling somebody you kind of screwed up, it's not well received. So a lot of times I'll go to, if I find something that might be not a showstopper, but something that I can identify to the construction manager, hey, you have all these conduits laying in the field. None of them have caps on. You need to have caps on the conduit. I'm not going to write it up. I'm just mentioning it to you because what happens is you get dirt and debris, and then you try, or varmints, they die in there. Construction material somehow manages to find its way into anything that's around, and then you're pulling your cable around that. And then when you measure the cable and it fails because you scored the outside jacket, now you have to pull the cable back in and put a new cable in. So if you just put the caps on, which you should do anyway, but it's not something that I necessarily I try to work with people without trying to make it there are some people that show their work to the client by trying to say, here's my list. I found 500 things. Well, if I find a bunch of things, on some of the lesser important ones, maybe it's worthwhile me just talking to the supervisor that's there and saying, hey, maybe you want to do this. We had something where I had a guy on a FAA tower, and he was trying to get to a panel, marshalling panel, that he had to do some wiring in. So he was standing on a transformer while he was doing that. Well, the transformer wasn't meant for somebody to walk on. And the enclosure actually started to bow, as you can imagine. Plus, he was actually above the level where he's supposed to be harnessed, because the transformer was about 6 feet, so he's standing above that. So I went to the supervisor and says, this is a safety issue. You really want to look at this. I'm not a safety guy. I'm just mentioning it to you so that you can preclude that happening. I didn't put it in my report. So if I saw that the guy didn't do anything about it, I probably would have put it in my report. So some of those are the types of things that we kind of work on, but the value added for anyone coming along, and that's why I say this is a whole program, the startup guy, letting you know that, hey, I'm starting something up, but I'm going to be starting up these process tanks, but I'm not going to have all the chemicals I need until X. Are you okay doing commissioning where you're doing some of the checkout before we actually have all of the chemicals, or do you really need to wait for the chemicals? And then that's a discussion. Anybody else? Yes.
Hey, John. Yeah. What I gathered from the presentation is that it's easy to break down the silos once you have a large budget. Of course, FAT testing, there's a lot of good things you mentioned with third-party vendors coming out on site, the tab contractor, for example, following commissioning. But what is one thing or one method that you recommend when you're running on a tight budget and, commissioning's coming on at the end, everyone's scrambling. How do you get that buy-in and that collaborative, insight that you want to build for everyone to reach that common goal?
When you're not able to build it into the program itself by having that kind of, the functions that I mentioned and how you can maneuver and manipulate some of the functions so that you have that kind of interface, what I've found is having a good kickoff meeting and describing the commissioning plan and going through what the roles and responsibilities are. So the plan has to be good. You have to actually say, designer, this is your roles and responsibility, because again, commissioning is the effort for the whole project. Here's your role and responsibility. CM, here's your role and responsibility. Vendor, here's your role and responsibility. And here's when they actually interface with each other. When we're in the design phase, this is what we need to get. We need to get submittals. Commissioning guy needs to get submittals when everybody gets submittals. You don't want to give me the submittal after you already approved the submittal and it's for record, because then how do I make a comment on it? So you want to have that kickoff meeting and actually have it being something that's not just, well, hey, this is John Hitsos, he's the commissioning agent, everybody say hello. You want it to be something where you're spending a good amount of time and actually going through kind of this work plan that I just showed here on the bottom, and show how, as you can see, each square is actually color-coded, because what I'm trying to show there is there are different people's responsibilities and how we interface with them. So you want to make sure that they understand that when the designer gives his design, they're still supposed to be around to make RFIs. If you decide that there has to be a change for whatever the reason is, or you're not sure of what the change should be. We have a UPS on this project I'm working on, and the contract spec says 15 minutes battery. The shop drawing says 6 minutes. Is 6 minutes okay? All I can point out is the variance. But before they gave that 6 minutes, and before they submitted that, they should have asked for a substitution or a waiver on that spec requirement. So letting people know that as they're getting equipment, all of these, excuse me, that's being the Italian in me, all of these functions where you want people to interact with each other, to understand what the consequences are of missing something like that and not interfacing with that, so that a good kickoff meeting, especially on tight budgets, will really help you out, as well as making sure that the necessary people are at the various meetings when you're having construction meetings. A lot of times they'll say, well, commissioning doesn't have to be at this meeting until the very end. Well, it'd be nice for us to be following that up as we're going along and identifying to the client, at least I know with my company, we in our budget, we have an allocation for meeting times. Some people assume that they can just kind of fall into that a little bit here or a little bit there. If you have a job that's a year long, it's very easy to have 24 meetings, 36 meetings, 48 meetings, each one of them an hour long. You have to allocate that time. You really do want to have the various elements available. You want to have the design engineer, you want to have the contract manager, you want to have the commissioning guy. You want to have them talking together as much as possible, so that if the program itself doesn't say, give me your protocol, go to this FAT, at least as you're talking, you could say, okay, I understand what you're doing. And I want you to know that if you have an automatic lid on a tank and that lid is broken, I can't do my commissioning on that tank until you're ready. So you kind of work it out that way, and now you're doing it as a kind of day-by-day type of thing rather than overall program thing. Anything else?
Thank you.
I think we're done. Thank you very much, everybody. I appreciate it.